for you guys. After talking about the differentiation of polynomial function, differentiation of exponential function, today let's talk about the differentiation of logarithmic function. So we have seen the differentiation as the change of the function with respect to the variable and in a given interval. So today we'll talk about the logarithms. We have notation of logarithms. We have two notation of logarithms. We have a logarithm in a common base where we have a logarithm as a log, logarithm of a in base b. So here we have two types of logarithms. We have one logarithm which is in either base 10 or any other integers, like the logarithm of a in base 10, and we have another type of logarithm which is logarithm in base e, where we have logarithm of a in base e. So this is called, normally we call this common logarithm, while this one we call it natural logarithm. For natural logarithm, let's focus especially on natural logarithms. For natural logarithm, where we have log in base e of a in base e. Normally this is equal to, we write this, instead of writing log in base of a in base e, write ln of a in this base. So when we're going to find the differentiation, about the differentiation, if we have y which is equal to ln of x, then how do we find the y dx? The y dx we write as 1 over x. So where do we get this one? Normally the main property says that if we have ln of u derivative, it is equal to u derivative divided with u. So it means this x here, we have here as x is the one that is made with its derivative, and we know that the derivative of 1, it is automatically equal. So the derivative of x, it is equal to 1, and we divide with this x. We divide with that x. So this is the same as when you have to make the differentiation of if y is equal to ln of f of x, ln of a function. So here, that is where we apply this property, and if only this u is equal to x, we only write 1 over x. That is where we have the y dx is equal to d of f of x we divide with this f of x, like that. That is the property of finding this differentiation of a logarithmic function. This is how we differentiate a logarithmic function. Let us take an example. Let's have an example. If y is equal to ln of 3x, then the y dx is equal to what? The y dx is equal to what? The y dx will be equal to, according to this property here, we take this 3x as u, we take that 3x as u, which is this one, then we write that 3x derivative, then we divide with that 3x here, which is this 3x. And this automatically gives a derivative of 3x. We get 3 times 1, because the derivative of x is 1, then we divide with 3x. And this is equal to what? 3 times 1, it is equal to 3. We divide it with 3x. Then you see that here we can simplify this with this one. And we get the what? dy dx is equal to 1 over x. So this is the differentiation of that equation. Now, this is one example. Let's take another example so that you can understand better. Let's take another example with a complex expressions. Number B, differentiate with respect to x. Differentiate with respect to x. Let's take y equal to 2x squared ln over x. Y equal to 2x squared ln of x. How can we differentiate this one? So, when we are going to differentiate this, you see that we have two functions which are multiplied. And automatically, you see that we are going to apply the product rule. We let this called one term u, and this is called another term v. And you know how we differentiate with the product rule. When you have u times v from the formula, derivative u times v from the formula derivative, it is equal to u derivative times v plus v derivative times u. So that is what we are going to do here. We are going to take this from there. We are going to find that dy dx, it will be equal to u derivative here, u derivative here, that 2x squared derivative, which is this one, we multiply with v, which is ln of x, then we add ln of x derivative, then we multiply with u. This is v that is added, then multiply with u, which is 2x squared. So this gives our dy dx, it will give, we drop these two. If you remember very well about how we differentiated the polynomial function, when you have a variable with a power, we drop a power, subtract 1 from power. So when you drop 2, multiply with 2. These 2 multiply with 2, we get 4. These 2 multiply with 2, we get 4. We remain with x power 1, because it is 2, negative 1. Then we multiply with ln of x, which is this one. Then we add the derivative of this, it is 1 over x, derivative of ln x, that is what we have seen from the starting of this session. Then multiply with 2x squared. So you see that our dy dx is equal to 4x ln of x plus this one, and one of those two x's can simplify. This one, one of these two x's can simplify, and you remain with 2x. We can write like 2x, we can put 2x as a common factor, remain with 2 ln x plus 1. This is our dy dx. So, thank you very much. Let us meet in the comment section. Let us meet there, and if you have question, if you have a suggestion, you can provide it. If you have any problem, you can bring it, and we can continue sharing ideas. Don't forget to subscribe, don't forget to comment, don't forget to add, like, and don't forget to share. Thank you very much.